Hi everyone, in this video we will be solving absolute value inequalities, so less than or greater than. Okay, but first reviewing an equation, so an absolute value equation. So if we undo the bars, we're going to get two cases. We'll get x minus 3 equals 5, and we'll also get x minus 3 equals negative 5. So the pattern is to take whatever's in the bars, take them away, and you get 5 and you get negative 5. So adding 3, we'll get x equals 8 for one answer. Add 3, and you get x equals negative 2 for the other answer. So your two answers. Graphing these on the number line. Okay, so one answer would just be at negative 2, and the other number would be at 8. And we could think of these as boundaries. So for inequalities, the question is, when are you inside the boundaries over here, or when are you outside of the boundaries over here? And that's what we'll be figuring as we go through some examples. Okay, so first example. Okay, so we're going to solve this similarly to the equation we just did. So x minus 3, bring down the symbol, less than or equal to 5. X minus 3 greater than or equal to negative 5. So solving these, we'll add 3, x is less than or equal to 8. Add 3, x is greater than or equal to negative 2. So we can think of a number that's both bigger than negative 2 right here and smaller than 8. So this is 2 that overlap, and this is and. So both things could happen. So graphing this on the number line, we'll have negative 2 with a closed circle and 8. So here's our boundaries. And since these overlap, it's an and, we graph in between. It turns out we can generalize this that whenever we have absolute value and we have less than, we can automatically conclude that it is an and problem. So here it's the same problem, only instead of having less than, we have greater than. Okay, so going through it, we have x minus 3 is greater than 5. And for the negative case, just like the prior example, we're going to flip the sign. So we'll have x minus 3 is less than negative 5. So for the negative case, flipping, it goes from greater than to less than. And if we take a look at what we did at the prior example, we see that we flipped for the negative case also. So here's the negative case, and it went from being less than or equal to greater than or equal to. So always for this negative case, we're always flipping our inequality. Okay, so solving these individually, so we will add 3, and x is greater than 8. Add 3, and x is less than negative 2. Okay, so we have the same boundaries on the number line, so we're at negative 2 and 8, but this time we're either less than negative 2, so we're graphing it this way, or we are greater than 8, where we're shading it dark, greater than 8. Okay, so we see that we have an or problem because we're either going one way or we're going the other way. We can't go in opposite directions at the same time. And generalizing, whenever we have greater than or equal to with absolute value, it's always an or problem. So in this example, just because it's less than with absolute value, I can automatically write that it's an AND problem. So whenever we have less than or equal to with absolute value, we have AND. Greater than or equal to with absolute value, we have OR. So undoing the absolute value bars, we'll have 2 minus 3x is less than 10. And for the negative case, 2 minus 3x is greater than negative 10. So I flipped it for the negative. Okay, so solving these individually, we will subtract 2, get negative 3x less than 8, divide by negative 3, divide by negative 3. Dividing by a negative, I have to flip, so now it flips to greater than, and that's greater than negative 2.6 repeating. Okay, solving the other one, minus 2 cancels. Negative 3x is greater than negative 12. Divide by negative 3, divide by negative 3. And x is less than 4. Again, I divided by the negative, so I had to flip. And that's AND. So graphing on the number line. These are open circles because they're not equal to. And it's bigger than negative 2.6, but less than 4. So it's this region that's overlapping that shows why it's an AND. In this problem, we have absolute value with greater than, so we can automatically conclude that it's an OR problem. Okay, so first we want to isolate and get the bars by itself. So we have to undo the plus 1 and the times by 3. Okay, so we'll first minus 1. So that gives us 3 absolute value of x greater than or equal to 9. Divide by 3, divide by 3. So absolute value of x is greater than or equal to 3. So undoing the bars, we have either x is greater than or equal to 3, or x is less than or equal to negative 3. And we need that OR in order for it to be correct. Graphing it, so negative 3 and 3, we have closed circle. X is either smaller than negative 3, going that way, or x is greater than 3, going this way. So main ideas in this lesson, one is that we have to flip for the negative case. And we saw this here, for example, we're writing negative 3, but we're flipping it from greater than to less than for the negative case, always for that second time that we write it. Another main idea is less than or equal to is always an AND problem, rather than greater than or equal to is always an OR problem. And that's only with absolute value. So here's an example of less than, and it's an AND graph, versus here's an example of greater than, and it's an OR graph going either way. See you in class tomorrow.